Mac version 29. Okay, so again, some of you may have a PC version. Okay, and so it's going to be important that you may see a little different look. Again, please mute your lines, be courteous to others so that we have a safe, friendly, and non-intimidating learning experience. We're not having a general statistics session here. And by that, I mean, we can't just start going into a lot of questions that kind of get out of the scope of what we're here for, and that's the one sample t-test, okay? And again, the anonymous survey. So again, as we mentioned, our goal is to get from the left here to the right when we start talking about statistics, okay? Having done this for over 30 years and being a psychologist, I really believe that once we ease our anxiety, we free up our cognitive energy, and we're able to focus more on the task at hand. So we're trying to get from the left face here to the right, and hopefully we will achieve that. Now, this is a very good introduction into the section tonight, because this is going to almost resemble a repeated measures t-test. So each of you right now, if I was to ask you on a scale of 1 to 10, what is your anxiety level right now regarding, say, the one sample t-test? Now, I don't know, but again, if it's something, that I'm not too familiar with, I might say a 3, okay? But then after this session is over with, you can be asked that again. Now, what is your anxiety level? We would hope, let's say the anxiety level was 8, very high, okay? We would hope that at the end of the session, that the anxiety would now be something like perhaps it went down to a 4. And what we've done is that we have repeated the measurement. Remember, repeated measures t-test. So I have taken the measurement once here, and I've taken it a second time. And that's the concept of a repeated measures t-test, okay? That what you are trying to do is to see if something has changed over time. So let's think about that. Interventions can be looked at. We may go on a weight loss program. What was your weight before the program? After the 6-week weight loss program, what was your weight after that? Before and after. You've heard the terms pre-test, post-test. That's what we're going to be talking about here this evening, okay? Now, when we start talking about the test, but before that, we know the scales of measurement is important. And when we look into SPSS, as we will do here shortly, we'll see that in that measurement column, that each variable is going to have a measurement, either nominal, ordinal, interval, or ratio. And I'm just going to start with the nominal here, and that's a categorical variable, such as a male, female. And you're collecting data, and you ask them, what is your gender? And they're going to say, I'm a male or a female, or they may have a third category, non-binary. But anyway, it's a categorical response, or it may be such as high or low, or as simply a yes-no response, categorical. And then we start going to the ordinal rank. Many of us have completed Likert scales before on a scale of 1 to 10 or 1 to 5. How satisfied are you, or how likely are you to do this or that? That's an ordinal. Interval, we have equal distances between the numbers, but no true zero value. And that's important, such as weight, as weather. If we were to be conducting research and collecting the temperature each day, 0 degrees does not mean that there is no temperature. It just simply means that it's cold. But then the final is the ratio, and that's equal distances and true zero value. And this is the variable, the scale of measurement, that is required for the paired sample or repeated measures t-test, the ratio scale of measurement, okay? So make sure, and we'll look at that when you get into a data set, that you are selecting a ratio scale, and we'll look at that. And here's an example of a slide looking at SPSS and from the variable view, but each variable has a scale of measurement, and you've seen this before. So in this case, you can see for example, or item number 6, it was easy to do something. But as you can see, that was an ordinal scale of measurement, ranking order. Now, you also see that something was in here as a nominal, but what's missing is the interval and ratio. And what's happening is that in SPSS, in the measure column, you will not see an option for interval or ratio. What you will see is the option for scale. That's the option you would select if you have an interval or a ratio scale of measurement, and that's what you would see in SPSS. So again, while there are 4 scales of measurement, the nominal, the ordinal, the interval, and the ratio are comprised all within the scale, okay? Now, what is this repeated measures t-test? Let's talk about it a little bit more to make sure we understand conceptually what it is. Now, what it is, it's a test, an inferential test, and it compares the means. Remember, when we did the descriptive statistics sessions and we talked about comparing the means, we know that the means is the average. And that's what we say in statistics, but we mean comparing the average score between 2 related groups. And the key is related, and that's important. On the same continuous or that scale dependent variable. Now, for example, we showed the example of when we went to the slide here, looking at going from anxiety before and after, or pre and post. So this is what we're doing here. These are related groups. Now, why they are related is because this is the same individual that's going to give me a pre number and a post number. You are related to you. That's what we mean. The second person is going to give me a score, 6. But that next score is going to be related and belong to that same person. That's what we mean by related groups. Does everybody understand that concept before we move on? Okay, fantastic. And this is called the repeated measures, or you'll hear it called the paired samples. And what it is that you're just pairing the responses from the first measurement to the same response in the second measurement. And that's, again, the repeated measures t-test. And that's what it is and why you would use it. So you can probably think of a host of different type of topics now that can be used to compare. A reading intervention in school. You know, you measure reading scores or something. You give the students a 6-week intervention on reading, and then you retest reading, and you're hoping that the reading will go up. So again, repeated measures. Again, I'm going to keep emphasizing that we're repeating, but what we're repeating is the same measurement, not a different variable as the second measurement or the third. It's the same measurement. And we're hoping that in between those measurements, something has happened to change that post measurement. That's conceptually what you are doing. So basically, in here, something is going on, an experiment, a policy change, or something. But we don't assess cause and effect with this type of test. But we're saying, you know, before the pandemic, we had something going on that we measured. Okay, we had the pandemic, and then after the pandemic, we measured something else. Again, it could be a host of before and after measures. So I just want you to start thinking about the possibilities, okay? For example, scores on something in the month of May, but the same scores on that same measurement in September. For whatever reason, you know, Audrey has entered that. That would be an excellent example. Yes, before and after. Okay, so 2 time frames. Now, one of the things about that I always tell individuals, especially when you're starting to conduct research, is that it's a very powerful test, meaning that you're very likely to find that significant finding if you do some things right, because each person is its own control. Remember, when we look at this is the same person. So you're not different from yourself. There's not a lot of systematic differences. I'm not comparing a male against a female. I'm not comparing, a student at Walden against a student at another school. All those systematic differences are things that can come into play that could really be changing the outcome. And that confuses us. But when we keep those systematic differences minimized, meaning how different are you today from yourself tomorrow? Not very different. So that's why it's a very powerful test. And you'll find that if you're challenged with sample size, that because it's powerful, smaller sample size can usually be used. Okay? Just threw that tidbit in there for you. Now, let's take a look at that example here. Now, first of all, we have an independent variable. Now, this is confusing here because what we say is that the independent variable is what we call time. Time. And you say, what do you mean by time? Well, what we mean is that we know that a variable has to have at least two measurements. So what we call it is time, but it's two conditions or two measurements. Time one, which is the pre-test, and time two, which is the post-test. Now, even though we know we're measuring something, but we're measuring it at two different times, and that becomes the independent variable, time. So in other words, you're comparing time one against time two, and that makes it an independent variable. This could simply be comparing gender, males to females. But that's not the case here because we have related samples, so it's time. Now, we're going to use an example here saying that we are concerned about our fear of statistics, okay? We have a fear of statistics. And we come to Dr. Taylor's seminars, and we hope that we can lower our fear of statistics. So what we have to do is that in between measurements, we measure your fear of statistics. And so if some of you put some numbers in here, for example, 3, Elaine said 7, Melanie 6, 8.5, etc. If you put those numbers in, then when we finish the seminar, you would tell me your numbers again. And then we could use those numbers to see if this seminar was effective in reducing your fear of statistics. Does everybody understand that? But let's look at that now in a data file. Now, here's an example of a data file. And as you can see here, we have fear of statistics in this first column. And we took a measurement. So person number one had a score of 32. After the seminar, the individual's score was 28, went down, okay? The second person, fear was 37, it went down slightly, 36. And so you can see, conceptually, we've taken repeated measures, okay? So this is the independent variable here, but it has two levels, time one and time two. Is everybody good up to this point?
Dr. Taylor, I put in the chat, so is that considered the two conditions?
Exactly, yes. It can
Okay.
be the two conditions, the two levels, exactly, yes.
Okay.
So there we go. Now, but what we're concerned with is that, we know that the scores are going to change. So there's going to be, let me find my mouse here. We know that there's going to be a different score. So 32 down to 28 was a reduction of 4. And so everyone would have a difference score. And this is the score that we're concerned with. How significantly different is this difference score? And that's what we're trying to do, okay? Now, so we could ask a question such as, is there pre-test and post-test difference? among a group of students after. Remember, something happened in between this pre and this post test here. Something happened in between here, okay? And after you attended the repeated measures quantitative seminar. Now, let's look at your scenario. If you're taking the research course this term, what you're being asked for the repeated measures t-test is that you're going to be looking at a variable called mathematical utility, whatever that is, okay? It's a measurement of math, it's some measure of math. But notice the two times are going to be the freshman year, and then 4 years later, the senior year, okay? And we want to know, so this is the independent variable with the two conditions, the freshman year and the senior year, and we want to know if the math utility score differs significantly. Okay, and then they said the higher levels indicate higher level of math utility. So does everybody understand now from what we discussed what this scenario is asking you to do or what the scenario is stating here? Are we okay with that? Everyone comfortable? Okay, I take silence as being golden. And I see some responses. Okay. And then you have application assignment, using the longitudinal survey. And then again, you're going to respond. You're going to actually have to run that test and then note the relevant statistics, comment on the meaningfulness, and include your output. And that's what we're going to address on how to do that. But again, I just wanted to make sure that you understand conceptually what you're doing. And I'm more concerned about that rather than just clicking buttons, but not really knowing what you're doing. Okay. So we understand that. Now let's take a look into the database. Now, what I have here is the I guess it's the high school longitudinal study. And what I'm in here now is what we call the variable view. Okay, and this is where all the variables are listed. And I just kind of move them around to get them to the top. But you see here, this is the the mathematics utility. But you see the T1, I guess they've labeled that's time 1. So that would be when the individual is the freshman, I would assume. Okay. And then we have the same variable, time 2. You see that scale of the student's mathematical utility times 2, the second time. So these are the two variables that you would use for that application assignment. Again, it's asking for the mathematical utility. Does everybody see that? Now, I have moved these variables around in the data set just to bring them up to the top. Now, if we go to the data view, we'll see here the field statistics scores for person number 1 was 50, and the second score was 48 for person number 2. So does everybody see now that relationship of how the data is in there? And these would be the two variables that we will be using in our analysis, field statistics 1 and field statistics 2. Okay? So now, the way a question could be asked again, is there a difference in the mean field statistics score between the pre-test and post-test scores after attending this seminar? Remember, you'll hear the terms pre-test and post-test. If you ever see those terms in research when you're reading, it's probably a repeated measures test. Something was measured before and after, and someone is looking to see if something that happened in between, is associated with that change, in that post-test score. And of course, there would just be the corresponding null that there's not, and the alternative that there is a difference. Now, remember from last night that we also had to address data assumptions because it's what we call a parametric test. And parametric means that it comes with a set of assumptions that we have to assess and test before we actually run the paired samples t-test. Now, not surprisingly, the assumptions for the test tonight is pretty much the same as the one for last night, the t-test. You know, it's the same type of distribution. So again, remember, these are design issues that you don't have to worry about in SPSS. You just make sure you select an interval or ratio level variable, which we know is the scale. Okay, this is nothing you do in SPSS to test it. You make sure you select the right one. And you don't have to worry about this really. But again, you would also make sure that you have two related groups, and that's obvious. You know, the pretest, and when we say groups, remember we're talking about the group 1 is the pretest measurement, and the group 2, or what we call the matched pairs. We're matching each person with themselves. Now, we know that before we run this test and address and answer that research question, that we have to assess assumptions. And these assumptions are outliers in normality, which were the same assumptions as last night. So there should be no significant outliers. And I'm going to underline this word differences between the two related groups. And when we talk about normality, you know, that normal distribution, the differences should be normal. Now, what do I mean by that, and why am I emphasizing that? Because many individuals, let's go back to this slide, and this is the slide that will help us understand that. Notice that I have the raw score here for Field Statistics 1. Many individuals will start checking for outliers for this data. That's incorrect. They'll then also check for outliers in normality for Field Statistics 2. What you are checking for in this test against the outliers is the difference score. Is the difference score normally distributed? Are there any outliers in the difference score? Does everybody understand that concept? Okay, I see it many, many times of individuals saying this variable was normal or not, and this one was normal or not, but it's really the difference score. Everybody good with that? Okay, fantastic. Now, but we have to calculate that difference score. Remember, we're collecting raw data. We've got it for time 1 and time 2, but now we know that we need a different score. And from SPSS, again, remember how we do it here. We just follow the numbers with the arrows. It's to transform. You're going to compute a new variable. And then in the target variable, you're just going to give it a name. I just put difference. You give it whatever name that you can understand. And then you're going to take the variables from the left here. So we had the Field Statistics. So I actually took it from the left, put it over here to the right. Then I used my numerical expressions, and I used the minus sign. I clicked on minus, which gives me the minus. And then I took the second variable, Field Statistics time 2, and I added it. Does everybody see that? I basically just told SPSS to do some math for me. Subtract Field Statistics in time 2 from Field Statistics times 1. Okay? And when I hit OK, that's where you'll see that what will show up in SPSS will then be that column with the difference score. Does everybody understand that concept before we move forward? Okay. Now we know that we have our difference score. Now we're able to start assessing the assumptions of outliers in normality for the difference score. Now that again was the same thing that we did last night. Okay. And what we did last night was remember, I'm going to go into SPSS, but remember we did the analyze, remember descriptive statistics, and we hit the explore command. And remember when we did these in earlier sessions also, when we were doing descriptive statistics back 2 or 3 weeks ago, is you can see, you can take the variable here, and I have a difference variable that was created, and this is the variable that will go in here. And then under the statistics, okay, we want the confidence interval, of course. We want outliers, and it gives us that. But then also, when we say plots here, normality plots with tests. This is going to test that assumption of normality for us. And when we hit continue, and we go, okay, and now what's going to happen is that we get that output, and we can start seeing, remember when we looked at the box plots before in our previous sessions, and we see that when we have a box plot for the difference score, you see, what is that 29 there, if anyone remembers that attended the descriptive statistics session? That's an outlier. That lets me know that record number 29 in the data set is an outlier. Okay? And that's how you would detect that. Now, also notice that you get something called the test of normality here. It's not significant. Remember the Shapiro-Wilk test. So we know that we didn't violate the assumption of normality. So we're fine with that. But again, you'll be able to go back to this video and you'll be able to follow the steps and see. But also remember, we did this in descriptive statistics to see whether the data was a variable normal or not. The same thing. Now, assuming we've done that and we say, okay, now we're going to go ahead and now run the test. And these are the procedures for running. Well, first of all, when we run the test of normality, remember, here's a box plot. And remember, the little variables, or the cases that had outliers will have the little dot, and this will tell you that case number 16 in the data set is an outlier. So if this was the data set, and this is not the data set, but you would simply go back into SPSS and go to your data, okay, and then you would go to record 16, and you would know that this record 16 here is where your outlier is, and you could probably just delete it, like edit and delete. But we're not going to get into that here, okay? Now,
Dr. Taylor, will we have to do that for class?
you have to talk to your professor on that, okay? Ideally, yeah, but ideally, but we'll talk about that in a little bit. That's a good question, okay? That's a good question, so keep that in mind there. Now, so then remember the Shapiro-Wilk test of normality. We know when we violated anything that's less than 0.05 or equal to, this is a little bit over, so we're okay. Normality is not violated. Now, we're going to go ahead and we're going to now run the test. Very simple test to run. Because again, we know we start always in our analyze mode. We're comparing means. Remember the means for time 1 against the means from time 2. And we know that we want the paired samples t-test right here. Tells us exactly right there. Can't miss it. Okay? After that, when it pops up here, the paired sample t-test, we simply are going to put variable 1, the field statistics at time 1. We would drag it from here, put it in here. We would take the field statistics at time 2 and put it there. That's what you're going to see in SPSS. And we'll look at that in just a second in live view. But again, you always have the number, the narrative over here for you, okay? Hit options. Always want 95% confidence intervals, okay? And when we hit continue, this is the results. And as we did with the one sample t-test, we're now going to be able to look at this here in a few minutes and understand what we're looking at. So here we can see that the average for time 1, the mean score was 40.17. But after the seminar, it went down a little bit to 37.76. But what we want to know is that statistically significant, okay? We know that there were 29 cases or 29 individuals in the research. And again, remember when we did descriptive statistics, this is the standard deviation, how far on average, each score deviates from the mean. This is the results of that test. First thing we look at is insignificance. Was there a statistically significant difference between the pre and post test? I ask you. Yes, simple. P-value is less than or equal to 0.05. Now, let me find my cursor here. Okay. Now, the mean difference, you see fear 1 minus fear 2. The average mean difference was 2.4. Was the difference that each person, differed from their pre to their post. Here's the standard deviation. And remember, when we look at our mean score, what's important, and this is the meaningful piece. And what I'm going to do now is go back to the scenario. And this is where, when you look into your scenario, we're putting the relevant statistics. We're going to put those numbers in there. But what I want you to focus on when we say comment on meaningfulness right here, meaningfulness, okay? I'm going to really circle that. What we're talking about when we start talking about inferential statistics are things such as the confidence intervals. That's the meaningfulness of it. The effect size, and we're going to talk about that. As I mentioned last night, the statistical significance, the p-value, we all get excited about it. And really, to be honest with you, it's probably the most useless information that you can get. All this is a mathematical probability that when SPSS behind the scenes was doing its mathematics, it calculated this t-value. This t-value is compared to another t-value that the mathematicians said that a study like this with 29 people and the degrees of freedom of 28, blah, 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 there's a certain t-statistic that we're going to compare it against. So let's just say that t-statistic was 4.0. Well, because you exceeded that critical value of 4, that just simply tells you had a significant result. You cannot tell me anything about your topic, about your variables from these numbers. Now, where you can start telling me something about what this means in terms of your research is, first of all, talk about the confidence interval, the difference. We know the score is different, and we know that the average difference is 2.4. But we know that we're never 100% certain in the research, so we have something called the 95% confidence interval of this difference. And there is a video tutorial that we did a couple of weeks ago on confidence intervals. But again, what's that saying is that we don't know for sure. We know for sure that this is not the true mean, but we do know that going to the left, the lower end, that is somewhere between 1.513, and on the higher end, it's 3.315. So this mean difference can be anywhere between here in the true population. That's what that means. Now, what does a 95% mean? People say, oh, I'm 95% sure. No. What that means is that if you were to repeat this study 100 times, you draw a sample from this data set 100 times, you know that 95 out of 100 times that this mean score right here is going to be between these two values. Okay? Talk about that, and we'll look at that in a second. Now, the other thing is that what is the magnitude of the difference? That's the effect size right here. And we can see here that the effect size is 1.01, and that's a very large effect size. Okay, very large effect size. And what this is it means that it's about 1.0 standard deviations. Okay, so basically, the effect of this intervention was about 2 points in regards to the mean score changing. And this is what you want to understand. Now, what you do is that you write that up to show that you understand. Now, what I have here, again, is just that output replicated. I just wanted to put this all on the same slide so that we don't have to keep going backwards and forth. And you can see how this output up here turns into an APA results write-up, okay? So again, as you know, we did the other night, we just talked about what we did to examine, and we just really repeating what the question was, okay?
Dr. Taylor, can you go back to that other slide that you had?
Which
one-
one? This, which slide is that?
The one where it showed the significant and the effect.
Yeah, let me get back to that when I get through this, my thought right here. Just keep that thought in mind. Now, so you see, all we're stating here is what we're doing, okay? And you notice I even stated time 1 and post-test time 2. Now, I stated the independent variable was time with 2 levels, 2 categories, whatever you prefer. Remember, time 1 was the pre-test. Time 2 was the post-test. In between here, we did the seminar here tonight. Now, your dependent variable, it was the post-test score. We want to know that dependent variable, did it change based on what we did? Remember, the preliminary analyses are always the assumptions. We have to talk about that. The assumptions of outliers and normality. And remember, we ran a box plot. You'll report the results of whatever box plot you have. These are just examples here. And so in this case, I'm just saying the box plot indicated one outlier. Remember when we looked at that box plot that showed that one outlier? And then I can say what I'm going to do with that. In this case, I say I'm going to remove it from the final analysis. Okay? Now, I now have to say what happened with normality. The Shapiro-Wilks test showed no violations. Okay? So as you can see, the steps we went through, we are now just telling the reader what we did, giving them the context of what we're doing. Then we report the results. This is where it's so important when you're looking at journal articles to understand what you're reading because you're critically analyzing those studies. If you don't understand this, you cannot do a critical analysis. All you can do is repeat what you read and tell me all of this stuff right here, okay? But now I need to really understand the meat of the matter, okay? And this is how we get there. The results of the repeated measures test were significant, okay? We know that, remember, when we looked at the output and we saw the paired samples test, the results of the test were significant. See that? We can say that. And we say there was a significant decrease in the fear statistics from time 1. So this is before the session, and I just put the means and the standard deviation, which I took right from the descriptive statistics output. Difference from time 1 to time 2. And you see we state the means and the standard deviation for time 2. Okay? Now, this is the piece here. Remember, last night we were in the t-test family. So what you'll see is you'll see the T shows up first. You'll see later on as you start doing other analyses such as ANOVAs and things, this is going to change. So we know we're in the t-test family. From last night, anyone want to take a stab at what the 28 represents?
It's the degrees of freedom, your number of cases -1.
Exactly. So basically, what that is our sample size. Yes, the number of cases of the sample. So as you can see, 28, but notice we say here, the sample is 29. So yes, it's N-1. So from right here, just by looking at this, you know now that a t-test was conducted with a sample of 29 people. You know, that much more than you would have known if you just looked at that T28. But now we have to report what the calculated t-value was. And remember that t-value was 5.489. And behind the scenes, SPSS is comparing your calculated t-value against some other value to determine if it's significant or not. And usually that critical value of t, let's say it's 4, you've exceeded that, that will give you a significant result. Okay, but you don't need to worry about this, but you need to understand that that's where this is coming from here and what that means. Now, of course, you didn't put the p-value. The sig was less than 0.001. Straight from your output. Cohen's d is the effect size that we use for a t-test. It's the most common one. Here it says effect sizes. Here's the Cohen's d. We use the point estimate. Okay, 1.01. I just rounded it to 2 decimal places and indicating a large effect. I think Cohen says from 0 to 0.3 is small, 0.3 to 0.6 is medium, something like that. 0.6 and greater is large. This is even higher, 1. So that's a large effect. So now this means something. Not only did it work, but it's a very large effect. It changes the confidence by quite a bit. Now, you may have this 2-point change here in another research study that may not be meaningful at all. This is where you talk about the meaningfulness of it, but it's going to be into the context of your research. Now, of course, for an application assignment, you got to make something up. But again, I want you to understand that when we say the meaningfulness, and I'm going to go back to that slide, that what meaningful means is talking not only about the relevant statistics, which is the p-value, but also the effect size, the confidence intervals. And then you're going to include your relevant SPSS output in your application. Now, we've looked at that, but let's look at the exemplar. And these are the things that I give you for each of these sessions that may be helpful to you in your application. Now here you'll get the repeated measures t-test, application exemplar, okay? And again, read the forward, and I tell you that again, that there may be differences based on faculty, committee needs and wants, course requirements, et cetera, et cetera. But this is in general, what it should look like in the components that should be included, okay? So all I did here was just stated the question. Remember, I'm looking at t-test confidence here. You know, your confidence in conducting a t-test, okay? Before and after the t-test seminar. So we understand pre and post. All we did here is replicated what we did in the example on the slide. Tell us what we did. We did a paired sample t-test, you know, to compare the pre and post-test differences. Okay. Now, in the application, it tells you a little bit more about showing understanding of what the test is. So as you can see here, I just kind of put something here, and you'll have to find something to cite. And I just stated the samples t-test compares mean scores between 2 related groups, blah, blah, blah. And I provided a citation. Okay. Then tell me what the independent variables were. Again, was time with 2 categories, freshman year and senior year. Again, now I got this mixed up here because this should have been pre-test and post-test, but remember your application is going to say freshman year and senior year for the math utility, okay? And then, so we'll say the post-test confidence score was the dependent variable. Here we looked at the outliers, okay? And remember I said the box plot, and here's the box plot. And remember I said it was not violated. You don't see the little dots here with the case number. So that lets me know and gives me the evidence. So now you're putting a graph or figure in your results section to help add value to it, okay? And again, as you can see, the same thing. T, the 79 is the degrees of freedom for this output. This is the calculated t-value. We know it was significant. Cohen's effect size is 0.6. Same thing. that we did before, okay? Now, to help you to make sure you don't miss anything, this appendix says just check with yourself. Make sure that you copied and pasted the test of normality. Make sure you've copied and pasted the box plot, these things here, okay? And as you can see, they're copied and pasted here, okay? And I've taken those and I've put them in here, and they've been pasted here in this example, okay? So that's kind of an exemplar that can help you kind of get started. You adjust it, as you see fit. The other thing that I just wanted to show you is the cutting and pasting piece, and then also the syntax piece. Your application may ask you to provide syntax, and we talked about syntax in a previous session about it's really just the instructions of behind the scenes is being coded, and it gives you just almost like the computer program. Every time you press a button, SPSS behind the scene is writing the script to execute what you're asking it to do. That's the syntax. So let's just quickly show you how to do a syntax file. And from anywhere you are, let's say we're going to do the t-test. I'm going to go analyze. Okay, I'm going to go general linear model. Compare means. Okay, and analyze. Compare means and proportions. It says it like crazy here. Let me see. Okay, I'm not sure what's going on there, but anyway, I'll show you from another slide. Anywhere that you are in the procedure, let me see if I can find a slide that can help you. Okay, probably not. I'll have to close SPSS and open it back up, but I'll show you in a second. But anyway, when you have the output, it's simply just really a cut and a paste command here. So as you can see, I have, say, the test of normality, and I'm clicking on it. I'm just right-clicking, and I'm going to copy. And then I just go into my Word document or whatever you're going to put, your application in, and just paste. And you can see there's the output. So it's just a copy and paste command is all you're doing to get it at the end of whatever you're submitting for your application. Does that make sense to everybody? And does this not kind of give you a little bit better insight of where you're trying to go and what you're trying to do with the paired samples t-test? And remember, we were always talking about lowering that anxiety. So if we were to score ourselves before and after, we would want to see, did our anxiety go down? And that's what we're talking about here. Now, it was a question. Okay, there's something about I did not understand what you should have put on the freshman year. Yeah, that was just in the exemplar. I have a typo, I believe, in the exemplar. And I'm looking at pre and post test for a t-test score. And I think what I said here was freshman year and senior year. And that freshman and senior year is actually what you're going to be doing in your application assignment. Okay, you're going to be looking at freshman year and senior year. So that's just a typo there. Okay.
Where's the typo? Which one is the typo? It shouldn't say senior year, or it shouldn't say freshman?
No. Okay, from reading this, you're saying that what the t-test did was it compared t-test content between pre-test and post-test after attending the seminar. So what we're comparing is before the seminar and after the seminar, and not between the freshman year and the senior year. And where that typo came from is that if we go back to your application, what you're going to be doing in your application, let me get to that, is in your application, you're going to be looking at the freshman and senior year. Okay, so that's just the typo that I put in there. Okay. So again, remember, this is just an exemplar. You're going to put whatever variables you're going to use. You just need to understand that whatever my variables are that I say I examined, that these are the same variables in the same time frame. This is just a typo here, okay? So, but you need to understand that I did pre-test and post-test, but I'm not looking at freshman year and senior year. This is just a made-up example that I'm giving you of a hypothetical situation where we attended a seminar as we're doing and seeing if our confidence went up or went down. Okay, so again, this is the typo. So this would say time 1, instead of freshman year, it would say pre-seminar, pre-Dr. Taylor seminar, and time 2 would be post-Dr. Taylor seminar.
Okay.
Okay, so it's just a typo, but again, it should line with what we're doing here. And again, that's a good thing when we're looking at research and evaluating research and students are submitting it for reviews. These are the types of things we see, you know, these, okay, pre-test and post-test after you did this, but then you're saying this, you know, it doesn't align. So really what we could simply do is let me do that here. Let me, so that you don't have an error there. I'm going to send you the Word document instead of the PDF, time 1. And so I'm just going to say pre-seminar and post-seminar. Okay, and that would we save that. And now while we're doing that, let me do something here. And I'm going to put that in the desktop. And now I'm going to take that, and if you check into the bottom of the chat, I'm going to start putting these documents in there. So the first one you should see is that exemplar. Does everybody see that down in the bottom of the chat?
Not yet.
Okay, it should take a second.
Yes.
Okay, now I'm going to put the presentation in there, okay? And that should be the, you should see the repeated measures presentation also in there, okay? Does everyone see that?
Yes.
Okay, so those are the 2 things that should be of help to you. Now, what I wanted to do before we close, again, if you looked at the exemplar, now, tomorrow night, we'll be doing the exact same thing, upcoming seminar, but we'll be doing that for the independent samples t-test, which is the 3rd test in the t-test family, okay? We'll follow the same format, et cetera, et cetera. You have to register for this, so if you take this presentation, you'll see that here's the registration link if you haven't already registered for this session. So what we've done here today is we've talked about easing anxiety. That is the purpose, okay, of this. No one's going to sit down in 45 minutes, become an expert in that, but you have this video recording, okay, that you can always go back to. And remember, the scales of measurement, so important. And we need that scale variable. We talked about the concept of the t-test, a before and after. The data assumptions, normality, outliers, we know how to look at those through the box plot and the Shapiro-Wilk test. And then your your longitudinal data set is the scenario that has those variables in there. And we looked at that, and you're going to take that time 1 or time 2 or freshman year and senior year, whatever it is that they're asking you to do, and run the t-test. We know how to interpret the output, and we know how to turn that into an APA compliant result. Remember, focusing on understanding that what's important is not only the p-value, but to talk about the confidence intervals and the effect sizes. You have the exemplar, you know there's another session coming up tomorrow. Please take some time to fill out the survey to let me know that we need to continue doing these things if they work for you. The other thing I wanted to show you is that the first place that this recording link will be, if you would give me a second, it's going to be out here. And the reason I'm showing you this one here is this is where I'm putting them at first out here. We'll be out here at a YouTube site that I've put together, okay? And you can see the one sample t-test that was done last night. It's sitting out here ready to be looked at. Remember, descriptive statistics, all of these different things here, confidence intervals. So if you need any of that ancillary information, remember, go out here when you're talking about confidence intervals, look at this seminar, descriptive statistics, etc. So this is where this will be, okay? So other than that, that's all that I really have. I thank you for your time and attendance and attention. And hopefully these will be very helpful to you. And hopefully we have reduced that anxiety just a little bit. And if we were to do a pre-test and a post-test, hopefully we would get that significant reduction in anxiety. Okay? So please, I'll leave the classroom open a little bit so that you guys can get those documents out if you haven't pulled those out already, okay? And I'll see you tomorrow if anyone is going to attend tomorrow's session. And good luck on the upcoming applications when you have to do these. And again, like I said, let me know how you guys do on those and let me know how, you know, what else we need to do if you think that you need some additional instruction and some things of that nature, okay? So everyone have a great evening, and I'm going to
Dr.
go.
Taylor?
Yes.
Before you leave, I noticed looking back at the previous presentation, like the exemplar, it's not added to the presentation. Is there a way to add it? That
No,
for some
no, I'm going out on my own and putting it out on YouTube. I don't know how to do all of that. No, so if you need that, get it out the classroom. If not, send me an email and I can forward you a copy of an exemplar.
Okay, all right.
Okay? No problem. Okay, all righty.